Hi, guys. For a second, I had to make sure I was doing the right thing here, so I am. All right, yeah, I'm just gonna pick up where we left off in class and just keep talking through problems. Yeah, and hopefully this helps a little bit more. So we're gonna start here with integration and accumulation of change. Again, this is probably the biggest chunk of questions, so yeah, I'm glad we're getting to it now. So Riemann sums, remember that Riemann sums, they refer to like the definite integral where you actually have bounds. So remember the difference between a definite integral and an indefinite is that a definite integral has bounds here, and an indefinite integral would not have bounds, right? So an indefinite integral would just be an antiderivative plus c. A definite integral, you're going to figure it out and you're going to have an answer. Now they give you an example here that says you can just evaluate things in terms of pictures, which yeah, of course you are, but I don't know about you. Even though I could do this with a picture, I would prefer to just make this x squared over 2 minus 3x and probably plug in the 4 minus and then plug in the -1. However, if this was, you know, an absolute value, I might kind of be changing my mind. At that point, I might just want to draw this as an absolute value graph and then just calculate the areas, you know, of the triangle that would be up at the top and then the triangle that would be at the bottom. So again, if that was the absolute value of x minus 3, and let me make these bounds a little bit smaller. Excuse me. So let's say this was like 1 to 4. 1, 2, 3, 4. Then you would have your absolute value graph that does this, right? And then if you were only integrating from 1 to 4, you would just find the area of this triangle with 1/2 times base times height, ditto with this one, and add those two areas together. So sometimes it's great to draw a picture. If you were going to do something like this, you would definitely need to draw a picture, because if you try to do u substitution here, think about u equaling 4 minus x squared, then du is going to have an x in it, and we don't have an x outside here, so we wouldn't be able to use u substitution. So at that point, you would need to remember that x squared plus y squared equals 4 is a circle centered at the origin with radius 2, right? Because that's your r squared. Therefore, if you solve this for y, you get plus or minus the square root of 4 minus x squared. And then the top half, like if you use the positive square root of 4 minus x squared, that's the top semicircle. And the negative square root of 4 minus x squared, that is the bottom semicircle. And again, you can be asked reasonably, or you know, you could, I guess, expect to be asked things like from 0 to 2, or from -2 to 0, or from -2 to 2, or maybe they could be tricky and say something like 2 to 0, you know, in which case you're moving backwards and it's positive, so it would have to turn negative, and so on. But anyway, how would you be finding this area? You would say that the area of a circle is pi r squared, but then because this is a semicircle, you would only want half of it. And because you're going from 0 to 2, you're going to plug that in for the radius. Actually, if I'm going from -2 to 2, I would want half of the circle. But since I'm going from 0 to 2, that's actually a quarter of the circle, right? So the answer to this integral, so we can move on, the answer to this integral would be pi fourths times 2 squared, that's the radius squared, and then this is just 4, the 4's cancel, and your answer is pi, okay? If it went from 2 to 0, I would have been moving backwards, and then my answer would have been a negative pi. If I were integrating the negative square root from 0 to 2, my answer would be negative pi, but if I was going from 2 to 0, my answer would be negative, so it would be pi. And rewind if any of that needs repeated. I think you guys probably get what I'm saying. Okay, so sometimes pictures come in really handy. All right, with Riemann sums, they give you a little summary down here of left Riemann sum, right Riemann sum, and midpoint Riemann sum. But just remember that all that means is you're trying to add up bases times heights for rectangles, right? To get areas of rectangles, and you're trying to add them all together. So they have this little free response tip that says, a lot of the free response question give you values of a function in a table, and you've seen that already. So a Riemann sum could be used to approximate its integral using the subinterval shown in the table, even if the intervals aren't all the same length. So what they're trying to say here is if you have this table and you have some x values like 0, 2, 7, 8, 11, okay? And then you have whatever y values down here. And just make them up, like -1, 0, -3, 5, 4. Okay, so if these are your x's and these are your y's, then it depends on what kind of a Riemann sum they're asking you for. If they want you to do a left Riemann sum, you want to use all the heights on the left. So you would do, and then with the matching base, right? So this base is 2, where this base is 5, right? Because if you were to plot out these points, 2 is 5 away from 7. 7 is 1 away from 8, and 8 is 3 away from 11. So your bases are 2, 5, 1, 3. But your heights, if you want a left Riemann sum, it would be times 1 times 0 times here times here. So your base times height for a left Riemann sum with 4 rectangles would be 2 times -1 plus 5 times 0 plus 1 times -3 plus 3 times 5, okay, which is whatever. So that's a left Riemann sum. Now if you can, well, I'm just going to do a new color. I was going to undo a bunch of times, but that'll take forever. So if I want to do a right Riemann sum, I still have the same bases, but now instead of grabbing the height from the left, I want the height from the right. I don't want the height from the left, I want the height from the right for this one. For this one, I want the height on the right, and for this one, I want the height on the right. And if you need to draw it, if it doesn't make any sense to you what I'm saying about this one, and I'm talking about rectangles and I haven't drawn any, if it makes it easier, just draw it. It doesn't take that long, right? 0, -1, 2, 0, 7, -3, 8, 5, and then 11, 4. And especially if these were always increasing or always decreasing, it definitely makes it a little bit easier to draw these rectangles, don't get me wrong. But even something like this could, you could draw like a kind of roundabout picture that might help you. But the hint here, the free response tip, says make sure that your sum only has one fewer term than there are points in the given table. Because again, so my right sum is going to be this base is 2, but now my height is 0, okay, because it's the height on the right. And then my next base is 5, and my height is -3. Next base is 1, and my height is now 5. Next base is 3, and my height is now 4. And then I would add this together and get a my right Riemann sum. And then as far as midpoint sums go, you really would probably have to have an evenly spaced table if we were going to do a midpoint sum. Also keep in mind for midpoint sums that when you have, if you're doing a midpoint sum from a table, which is usually the case, let's say you had like 0, 1, 2, 3, 4, okay? For your midpoint sum, we can't even do like an M4. We can't have 4 things, one stretching from 0 to 1, 1 to 2, 2 to 3, 3 to 4. Why not? Because I wouldn't have all the y values that I needed. For a midpoint sum, again, we need base times height plus base times height plus, an indefinite, like not an indefinite amount, but however many base times heights you need to get yourself across that table. Well, here, if I have heights of, let me just say they're 5, 6, 7, 8, 9, if these are my heights, then if I'm going to use this table and give a Riemann sum estimate using a midpoint sum, they probably would not even tell me how many to use. They wouldn't say with 4 rectangles, with 2 rectangles, with 3 rectangles. They would want me to realize that I am going to have to figure out that I know that this is a rectangle that goes from 0 to 2. Therefore, 1 is my x value that's in the middle. And then they want me to notice that I have a rectangle that goes from 2 to 4, and that my midpoint for my x's is 3. Okay? So this midpoint sum, follow me here, my midpoint only has 2 rectangles, the one that goes from 0 to 2 and the one that goes from 2 to 4, right? And that would make perfect sense on a graph, right? You're going to have a rectangle here and a rectangle here. I think I just drew those going down and this would go up, but whatever. So I would only be able to do a midpoint estimate here with 2 because I can't assume that that's 5.5. It might not be. This might not be 6.5. This might not be 7.5. So since you can't make any assumptions off of your table, you have to go with what you have. Again, so now I have a base that goes from 0 to 2, but I have a height of 6. That's my midpoint. And then over here, I have a base that goes, I was trying to do another color. I have a base that goes from 2 to 4, but my midpoint for that, my height is 8. Okay, and then that's my sum, my midpoint sum. So with midpoint Riemann sums, again, they don't always tell you how many rectangles or where to stop or anything like that. Okay, I'm trying to keep an eye on the time. One, because Mrs. Sipes is going to start announcing things soon, and another is because this cuts me off at 15 minutes. Okay, so we can get through the rest of these, I think. The properties of definite integrals, these are really important, but again, make sure that you realize they're super easy. This isn't something you should have to stress over or study. Actually, let me even take this out of here. Something like this, you could just do this integral. I don't really think this is a very necessary property. Like, this is something you kind of be able to figure out. You'd be able to figure this out. This is common sense. If you don't move, this says A to A, then of course your area from there to there is 0. Remember this property? I remember one of you questioning this. So make sure you guys all know this. If you're going from A to B, that is going to be the negative as if you went from B to A. I talked about that above in those circle problems. And then if you, especially if you put C between A and B, right, you would know that if you had some kind of curve up here, that if you went from, you got your area from A to C, and then you added your area from C to B, you would get your area total from A to B, okay? Now, if you remember problems where you had to use those properties of integrals, it would be in something like this. So I suggested to you at the time, I think, that you use a number line. So if we're going from 1 to 7, and that integral is 9, I usually just kind of mark them. So from 1 to 7, I have an integral of 9. From 1 to 4, I have an integral, and if they're not to scale, then they're not to scale. From 1 to 4, I have an integral of 12. So what is the integral from 7 to 4? If I were you, I have 1 minute to talk here, I would go from 4 to 7 first and see that like 12 plus x has to give me 9, so therefore x is -3, right? And then I would say, okay, finding the integral then from 7 to 4 is the backwards, so then that's going to give me 3, okay? All right, I'm going to stop recording. You could scroll down and look at their explanation, because a lot of times their explanations are a little bit different than mine. Okay, so there's my 3, there's their 3. You know, listen to what I'm saying, watch theirs, and see what you like better. All right, so I'm going to stop this. This will be the first video, and then I'll pick up with accumulation functions and the fundamental theorem of calculus next.